Hi, so let's talk about the reverse linked list too. So you're given a head of single linked list and two integers left and right, and the left and right are the position in the linked list. So for example, so left is equal to 2, right equal to 4, right? So at some point, you will know the list node value is actually equal to 2 and list node value equal to 4. And then you basically need to reverse the list of the single linked list inside a single linked list. So you have to reverse this and then basically connect the last one uh, for the beginning of the reverse linked list and then the last one to the end of the single linked list, right? So this is pretty much the idea. So how do you actually solve this? So this is supposed to be simple. So again, there are many solutions, but I like to use the recursion solution. So I would definitely know like I will traverse all the way. Sorry. So I will traverse all the way to the beginning, which is the left, right? So I will be able to know this is the position that I need to start with, right? I need to reverse, right? And again, I will have to traverse at the end, but I also remember the next position, the next list node that I will have to connect after I reverse, right? So I'm going to call this successor. This is the list node I will have to uh, connect after I reverse, right? Then basically I will just keep changing my next pointer back to the uh, just back to the previous one, right? And then at the end, after I reverse, I will just connect this one to the 4 and then 2 to the 5. So this is pretty much the idea. So I'm going to just talk about how I do the reverse. So again, the only thing, the hardest part is how you reverse, right? So I will have to, I will have to like changing my next pointer every single time, and then for every single time I will have to point my previous one to the successor. But again, when you go on the backtrack solution, right, and you will have to change your next position, the next pointer back to the beginning, and then you will just point the current one to the successor again. And again, you definitely need to keep doing the rest of it, right? And this is pretty much the idea, right? And let's start coding. So I need a helper function, and this helper function is going to call reverse and I need what? I need only two arguments. One is the head, the other one is n, right? So if head equal to null for the main function, I will just return null, right? And for every single time I traverse from the linked list, even though the current list node is not at the beginning, right? I will just have to decrement my left, decrement my right. So every single time I will just check my head.next. So reverse between head.next, right? Comma, and then left -1, right -1. And at the end I will just return the head, right? I'm not allocating list node for the head. And I do have a successor equal to null. This is going to be used in the reverse one, right? So again, once I find my beginning of the reverse linked list, I will have to do this. So well, left equal to 1, right? I will have to reverse using the reverse function and passing the head and passing the right. So the right is based on the length of the linked list that need to reverse, right? And I will come to here, right? And then I will have to know what is my the last node I need to reverse, right? So reverse and head.next. and then a minus 1. And then at some point, so just for example, 2 and 4, right? But I would decrement my what? Decrement my decrement by 1 because the first one does not need to reverse, right? So again, so this become what? 1 and 3. So I access this if statement, right? And I will reverse 3, right? I will have to reverse 3 nodes, including yourself, right? So for the base case is if n equal to 1, right? So I'm right over here, 1, 2, 3, right? So you have to include yourself. So if n equal to 1, right? So I have to remember my successor. Successor is actually the next one, right? So I'm actually at this position. I'm actually at this position right now. This is my last, and this is my okay. This is the backtrack solution. So this one is my last, right? Successor equal to what? Equal to the last one next, which is also head, right? In my current iteration, like current recursion iteration, this is also my head, but this is also my last one. And so I'm going to say successor equal to head on next, and then I just have to return the head. I don't have to change anything. I just have to know what is my successor listener, right? So once I find my last node, right? I'm going to backtrack, right, for the recursion. So I'm going all the way back to the beginning, right? So when I go back, right, I need to change my pointer. So just using this one. So right now I'm right over here, right? So I will have to change my this pointer to here, right? So again, this is easy. So I will just say head dot next to head, right? So I'm not adding this one, right? So and then I will have to change my head dot next. Hey, wait. My head dot next to successor. So why? This is because you will have to connect to your successor, even though this is not the list node you want to connect, right? And again, once you go another forward for recursion, right? So you're starting your recursion from here, right? So you will come back to this node recursion case, right? And then you will have to say head next. So this is your head right now, right? And let me erase this h. So you will say head next to yourself, right? And then you will say head next to 5. So again, this is easy, right? 2 to 5. This is the last situation, right? And then we already assigned head next in the main function to the last. So they just start looking at it. So I would say head next equal to what? Equal to head, right? And then head next equal to successor. And then you have to return the last. This is because you want to know the reverse head, which call like the head of the reverse, right? So again, when I reverse the entire linked list, my original non-reverse list node is already waiting, like which is my head next point at. So I'm gonna point at 4, right? So I'm gonna point at 4, and then I already know like my last reverse list node is already pointed at successor, right? So this is pretty much the solution. So let me start running. I have the typo. So reverse, and what else? So I think I spelled it wrong, right? Reverse just reverse, right? Alright, and submit. Alright, so let's talk about the time and space. This is only the space, right? So it's going to be what? This is going to be constant, right? And you are not like allocating every single list node for the last, right? So you only allocate the last inside the reverse linked list. So this is not come as all of one. So the space is constant, all of one. And then the time, this is going to be all of them. You do have to traverse every single one of it, right? And then you want to check, okay, is this a reverse one? No. Is this a reverse one? No. So this is all of them. Traverse every single list node. And I will see you next time. Bye.